To let you all know that I'm not usually a slide deck presenter. I mean, some of you, I'm sure, have seen some of my demos. Usually, I do live demos where I'm either running code before an audience against our network infrastructure, or I will write small, simple applications live, showing off our code base. Now, I don't think there's really any reason for me to do that today, but if there's something you really want to see live, I can do that. But if you feel like you're at a point where you already kind of understand what NuCypher is about and you just really want to see the how it works and the what it is kind of questions, do feel free to go to our YouTube channel and check out some of our demos. Now, as I say, I've done demos as recently as a couple of weeks ago, where where I really walk through some of that stuff in a pretty straightforward way. Of our last 6 videos on our YouTube channel, which I will post in the CoinList build channel here. Okay, so on our Discord, in the public channel CoinList build, I just posted a link to our YouTube. Of our last 6 videos, 3 of those are my demos, and they're fairly different from each other. So again, if what you want your primary takeaway to be from our time together here this morning is to not necessarily learn about what NuCypher is, but about how it works and sort of what is already done in the code base and what is functional, you can even drop out of this call right now if you felt like you want to, and go ahead and watch those demos, or of course watch them after the call. What I'm going to do now for basically the rest of the call, unless I'm getting a lot of feedback in a different direction, I'm going to share my screen and go through some very basic fundamentals of sort of like what NuCypher is and okay, how does this look for everybody?
Fantastic.
Okay, wonderful. So I am going to kind of go through this deck. I really do want people to stop me at any moment for any question, and you can do that. I wanted to be able to say you can do that in the Zoom chat, but unfortunately it's disappearing for me. So what I will have people do is go to the CoinList Hackathon, I'm sorry, CoinList build a NuCypher channel, and we can interface in there if you have questions, or if your audio is working, you can go ahead and just sort of pipe in if you feel like you're in a position to take the mic. So at a very high level, let's talk about NuCypher. We view ourselves as a data privacy layer of a ecosystem of decentralized apps, or you might even say, as we sometimes do, and as my slide does, of the decentralized internet. And so what that means to us is that we build privacy preserving and in some cases authenticity preserving mechanisms that are meant to be used in a decentralized way. The most sort of prototypical example of this right now is our NuCypher network, which we are deploying as an ERC-20 incentivized network on the Ethereum blockchain. But I do want to start off by just pointing out that we currently have functioning federated DevNet. We have federated testnets that our staking partners have launched nodes on. And there's really nothing particular about NuCypher that makes it any more of a fit for, say, one blockchain or one collusion prevention ecosystem versus another. So it's possible in the future that we will launch additionally on another blockchain, but we are definitely heading toward a mainnet ERC-20 launch on the Ethereum blockchain. And so if there are any questions about that, definitely let me know, but that's something we'll probably talk about a little later. Let's talk about sort of, again, high level stuff about NuCypher. Okay, and I know nobody wants to have slides read to them while they're already on the screen, but it's kind of what I have to do for this slide, right? So our mission is to build the tools developers need to make privacy-preserving applications that guarantee our fundamental human right to privacy. If you want to take a look at our mission statement, we kind of go into the way that we view privacy as its position as a human right, and the history of privacy for the privileged. And, we view the opportunity that we have primarily as one to build privacy and privacy preserving tooling that is not particularly meant for the privileged, and not particularly meant for the well-educated, and not particularly meant for the well-connected, but that is sort of network, lives on the network and is agnostic about those typical societal norms. Our core technology is our proxy re-encryption network, our data privacy and access control layer for decentralized applications. Now, we also are researching lattice cryptography and fully homomorphic encryption. We have, I believe, the fastest fully homomorphic encryption implementation in the world. Of course, it's still very, 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 very slow and not really useful for many use cases. But the reason that we include this here, to let you know this now, is that our proxy re-encryption network, which you're going to be using for the hackathon, is it is a first feature that stems from the research that we've done that we're rolling out. Now, there are other features that we intend to roll out later that will stem from research that is ongoing right now. Okay, and our team, by the way, I don't use any of these labels for myself, but we have people who traditionally are cryptographers. In other words, they come from the academic world. We have people who are distributed systems devs. In other words, they come from more deployment and development and testing and QA kind of background. And we have people who are security engineers, meaning they come from security research and hacking background. Pretty much all of us are some combination of these three. I mean, pretty much all of us. We have a team of 14, and I believe 13 have at one point or another opened a pull request. So we're a very generalist team. And for you, the reason that's important is because you need to know that you can wander into our Pound General channel and ask any of us for help. You're happy, feel free to tag me in particular, but you can ask and engage with anybody on our team for help. And we also have a pretty lively audience of people that have been watching and using our system for a long time, and many of them are happy to jump in for help, and we appreciate that too. Okay, let's talk about it. Access control. We're doing access control via threshold proxy re-encryption, and that sort of gives us this decentralized access control. Let's talk about how and why that is. The easiest way to think about it, or one of the easy ways to think about it, is to start with the limitations of traditional asymmetric crypto, with which you probably are familiar. Okay, this is a very, very simplified scenario here where we have Alice on one side, Bob on the other side. Okay, Alice and Bob are names that are tokenized names in the NuCypher ecosystem. These are classes in our code base. They are CLI commands. They are characters with specific powers to us. We sometimes use the word Charlie to just mean another Bob, okay? And that's what's happening here. So you won't find Charlie in the code base. So here's Alice. You're all, I'm sure, pretty, or I imagine, pretty used to this scenario that's depicted here. Okay, now it happens on a remote server. Okay, so we add sort of this trust relationship. We put a couple of boogeymen in the middle. Now we have something that's like decentralized storage, but on untrusted machines is what we end up with by dint of that. Okay, so proxy encryption closes this loop. Now we have a different scenario where we have Alice still encrypting for Bob, but what happens here is that Alice makes a rekey for Bob, a different rekey for a different Bob, or in here we say for Charlie. Then anybody is able to encrypt the message, and a proxy is able to re-encrypt for Bob, re-encrypt for Charlie. So again, Alice is no longer doing the encryption. Alice instead is making a, we say making a policy at a high level, but here on this chart, we're just talking about the cryptographic material. She's making a rekey so that the proxy can re-encrypt for Bob and Charlie. Okay, so what we're doing here is introducing two new characters, a proxy and a messenger. Okay, and so here are all of the characters. We have Alice and Bob, to whom I've already introduced you. Alice is the policy owner. Sometimes we say the authority of the policy. Bob is the data recipient. I like to say the biddler. That hasn't really caught on in our ecosystem, but I try to do the A and the B. But the reason that I say that is because Bob is the one that's sort of most likely to live inside your DApp because he's getting the data, and your DApp probably uses the data. Otherwise, why would you be building it, right? Ursula, our untrusted proxy re-encryption node, and Enrico, the data source. So the traditional narrative between Alice and Bob, we have broken out into 4 characters. If you look at the most recent demo on our YouTube, which again, I linked in the CoinList build channel, you'll see I have a demo where I have 4 terminal windows, and I spin up an Alice in one, a Bob in another, an Enrico in another, and an Ursula in another, and go through the entire operation. So again, if that's what you're here for, if what you want to just see is how it works, that demo is going to be good for you. You'll get to see sort of how all the cryptographic characters work. And again, just in case this wasn't totally clear, I do want to impress upon you that each of these, Alice, Bob, Ursula, and Enrico, these are classes in our code base. They live in NuCypher.characters.lawful module. These are the 4 characters that represent adherence to the protocol of the network. And so if you're accustomed to reading Python, you can dig in to see exactly how those characters work. And the codification of the protocol is right inside these character classes, right? So here's Alice and Bob and Ursula and Enrico. Okay, and I'm in NuCypher characters lawful. Okay, we also, I want to point out, have unlawful characters. These are characters that attempt to attack our network, attempt to exploit what we see as potential vulnerabilities that we discover as we go. So when we discover what we think is a viable attack, we codify that as methodology on these unlawful characters. So if you're working on NuCypher tooling as part of your hackathon project, it might be interesting for you to kind of check out what we test against. Okay, so Vladimir is an Ursula who doesn't follow the law. How's everybody doing? Any questions so far? Nobody has said anything in the CoinList build channel. Why doesn't everybody, I'm going to say, everybody cool so far? Just give me a thumbs up there if you're with me and everything's cool so far. If not, then, you know, let me know what I can do to be better. Yeah, cool, okay. All right, let's talk about data sharing here with public key encryption. What we're depicting here is a sender encrypts something with a receiver's key, puts it on a node somewhere, and makes its way to the receiver that way so that the sender can essentially be offline. Okay, so in this case, single node has access to the data, but the single node where it's stored can also deny access to the data. Okay, so people said, oh, well, we could do a proxy encryption with Shamir secret sharing. And so this kind of does an interesting thing where now there are 3 different nodes that are required for communication. But the problem there is that the nodes then can collude to gain access to the data. Sometimes that's okay. There are scenarios where that's okay. And we're not saying that Shamir secret sharing is bad in some way. It's brilliant technology. And in times where that's okay, that's great. And in fact, it's totally possible that we will build a Shamir secret sharing character down the road if there's enough demand for it. And that's the kind of thing we'd love to hear from you. If our proxy re-encryption character is not doing the right thing and you need something that's less secure but more accessible like Shamir secret sharing, you know, let us know because we can build that stuff. We are going to go to mainnet with just our proxy re-encryption scheme, but we're super excited to add whatever the next characters are down the line after we deploy it. So here's data sharing with proxy re-encryption. Again, this is what we're launching to mainnet with. This is our plan. Well, actually, this is single node proxy encryption. So this is not exactly right. We'll look at the threshold thing next. So without a threshold, now a single node can collude with the receiver, and a single node can deny access. Okay, so if this node says, no, I don't want you to have it, Bob can't get the message. If a single node wants to collude with the receiver, then they can, they essentially compromise Alice, the sender. They can manipulate the policy. So this is sort of our innovation, is threshold proxy re-encryption. So now you have one aspect of Shamir secret sharing, which is that the power is divided across multiple nodes. And in this case, this is Ursula. But you also have some of the power of proxy re-encryption, in the sense that it requires the receiver's private key to decrypt the message. The sender never sees the receiver's private key. The nodes re-encrypt for the receiver's private key, and the receiver's private key is needed to see the message. Okay, so this is now a scenario where the sender had to know the receiver in advance, but it also means that even if the nodes collude, they can't get the secret. Okay, it requires M nodes and the receiver. So take a look, try to absorb what's happening here. This is really just a sort of flow depiction of what we saw on the last slide. We have some ciphertext, and using the re-encryption key, we perform the re-encryption operation, and we get a different ciphertext. Okay, this is not plain text. This is not clear text. These are both ciphertexts. This ciphertext is the one that's encrypted by the messenger, by Enrico. This ciphertext is the one that can be decrypted only by Bob. Okay, now let's talk about the token. Back to this slide for a moment. What you see here is that we're trying to keep these nodes from, there's a couple things that these nodes could do if they ganged up. One of them is that they could refuse to revoke access to the receiver. So let's imagine that attack for a moment. We use the token as a staking token to coordinate the network. We allocate all of the work is that re-encryption operation, proportional to Ursula's stake in the token. We compensate honest nodes, we slash malicious nodes. Okay, so this is a very typical work token. The reason that we need a work token, the reason that the work token model works sort of really perfectly in the NuCypher scheme, is that we need to ensure anti-collusion. Really, it's an anti-Sybil attack from among the various staking nodes across our network. So that's the basis of the token. And really, our crypto economics are relatively simple. We do have some sort of flashy blockchain-y stuff that we do to verify the operation on chain, which requires some gymnastics in the math, and is actually very cool to read if that interests you. But generally, in terms of the economics of our token, it's a relatively straightforward work token. We do have an economic paper which we are still updating somewhat, but actually I think we are going to have that audited soon, so it's probably finalized enough to read. Okay, we have a demo that we do that's in our code base. You can run it. I don't plan to run it right now, but I will explain a little bit about how it works, because it might sort of signal you into a use case, and then if that is sort of politically similar to your use case, then you might want to run this demo yourself.
Hey, Justin,
yeah.
Sorry to interrupt, but there was a question posted in the chat that I just want to ask real quickly.
Sure.
The question was, do these Enrico get incentives for running and staking new?
No, Enrico does not participate in the crypto economics at all. Ursula stakes the token and performs the re-encryption, and Ursula does, what was it? Was the question about inflation? What was it exactly? I wish I could read it. I can't do screen share and see the chat at the same time. I don't know why. If you want to copy and paste it to the CoinList Builds channel, I'll answer any questions that come in there.
Yeah, let me do that right now. Done.
Yeah, no, Enrico does not get any incentives for running and staking new. Enrico is, it is possible for Enrico to be an entirely ethereal character. What I mean by that is, it is possible, if your application demands it, for each individual message to come from a different Enrico, who is then never seen again in the network and whose sort of personhood is never verified in any way. Ursula, on the other hand, in the upper right corner of the current slide, Ursula does run and stake Nu, and there is an incentive there are two incentives for running and staking. One of them is the reward. One of them is the fee that Alice pays for the policy per time, and the other is inflation rewards for the first, I think it's about 2 years of our network. So in this case, Alice, one of the incentives here is this arrow going from left to right. Alice, can you all see my mouse pointer? I'm acting like you can.
Yeah, we can.
Yeah, great. So Alice, Alice creates a policy that gives access to the doctor. In this case, that's Bob. She creates that policy on the NuCypher network, and at that time, she pays Ursula. She pays each Ursula in the policy. And our picture of that right now is that she pays in Ether, not in Nu. Then she hands out the policy public key to the various data sources. Okay, this is Enrico down here, your heart monitor, let's say, or any sort of other medical device that you might imagine. This stores the data encrypted with this policy key. Okay, and here we depict a side channel. It could be a centralized thing. It could be, you know, IPFS. It could be Swarm. But there's some side channel that's shared storage between the device and Bob. Bob gets the encrypted data. We call that a capsule. And Bob brings the capsule to Ursula, and he needs to bring it to at least M out of N Ursulas, just like a Shamir secret sharing scenario, to request re-encryption. But again, it's different than Shamir secret sharing in the sense that what he gets out is not plain text, but ciphertext that only he can decrypt. So one thing that's interesting here, and I'd love to hear for your projects, if you have this use case, is that you see here there's a separation between Alice, in this case it's the patient, and the medical device. The medical device doesn't have to know who Bob is, and Bob doesn't have to know who the medical device is. Alice can just continually grant and revoke from among various medical devices to various medical providers. It's kind of tricky to find great use cases for this, but I know they're out there. And one of the really cool things for us that hackathons have done is to help us sort of discover what those use cases are. Question in the channel right now from Travis. Would the data in Enrico encrypts already be encrypted with Bob's public key, or would the data be fully consumable by Enrico? Typically, typically the answer is no, it would not be encrypted with Bob's public key. That would be perhaps a more advanced use of NuCypher. But I have thought about that in the context of some weird online gaming scenarios, which is kind of where my mind goes for a lot of this stuff. Typically, the data is consumable by Enrico. So in this case, the heart monitor produces the data. It has access to that data. And then it encrypts data with the policy public key, not with Bob's public key. This way, if the heart monitor were hard-coded to encrypt for Bob's public key, then Alice could never really revoke without going around to all of her devices and reconfiguring them. And that's one of the problems that we solve. Additionally, the device would need to encrypt many times for as many Bobs as there are. Okay, that's another problem that we solve. And finally, the device would need to sort of know who Bob is. And in this scenario, there's a wall of separation there. So in answer to the question in chat, it's typically not already encrypted with Bob's public key, and it is fully consumable by the heart monitor. Although if you have some wacky use case where you'd encrypt it once with Bob's public key and then again through the network, boy, I'd love to hear about that. I thought about it for doing some kind of like, my head was going there the other day when I was trying to imagine like a playing card, like a collectible card game where you keep your own hand secret. But I don't know. I don't know if there's any use case for that or not. Okay, so here is our DevNet. This is what you can work against. Does Ursula keep a ledger of all the policies? Our current iteration of the network is such that all of the policies are reflected on the blockchain. So in other words, each arrangement, that's the word that we use, and by the way, policy and arrangement are both classes on our code base. Feel free to examine. Each arrangement that Alice makes, and she makes n arrangements per policy, those each are represented on chain in our current thinking. Down the road, we'd like to make an anonymized version where that's not the case, but there are a number of challenges between here and there, and it's not clear that the Ethereum blockchain will ever be quite the right space for that. Here's our DevNet. This is the network that you can use when you are, so all of the examples that you'll see in our documentation, they ask you to connect to a network. They ask for a domain, and then they ask for an address to a seed node. So these are the details for that. And I will post that in the CoinList build channel right now. Okay, so I think you probably mostly have already been here and checked out the details of the hackathon. Here's a bunch of important stuff. This is all also available on our Discord, which I think you are all on. Actually, it's also on the documentation, but just to go through it, our main website, NuCypher.com. Here's our docs, our proxy re-encryption network, our threshold proxy re-encryption project. So this is sort of the library that powers that network. And these are both links to GitHub, by the way. They're both on our GitHub, so you can just easily just go to our GitHub. Our fully homomorphic project, which is not relevant for this hackathon, but is super groupy and interesting, and is hopefully going to be ready maybe in a couple years or so. And our Discord, which I think you're already on. McLean gave his own email here. Here are, just to give you a sense of who is already sort of throwing their hat in the ring in our ecosystem and are working on projects, working on DApps. All right, so let's hear some questions. I've got one question already, but I'd love to hear some more. Let me know how I can activate you working on your project. Hello?
I wanted to.
I don't know if it's on my end or yours, but you have cut out there. All I heard was I wanted to.
Hi, Miles. We have another question we have posted on the chat. Can you please answer that?
For each policy, a key pair has to be maintained. Would it be difficult to manage this many keys in one place? Well, I don't really see why. It's true that a key pair has to be maintained if you ever intend to grant or revoke again. I will add a proviso here that it is total. You can actually delete those key pairs, and the policy will remain in effect on the network, throughout the duration that Alice initially granted for us. In other words, Alice can go offline completely, disappear from the internet entirely, and Enrico can continue to encrypt. But
sorry to interrupt you. Hey.
Yeah, sure. Go ahead.
I just wanted to ask you, should I recording this audio?
Oh, that's a good question. I'm sorry I didn't go over that at the very beginning. I think, if I remember correctly, that Justin said that he is recording it.
Yeah, I am recording this, and I will post it on YouTube afterwards for everyone that wasn't able to make it, and also for reference.
Yeah, and we also, our YouTube already has people sort of going through the same flow. The reason to go through it again, in my mind, is to give you all a chance to answer questions. I don't claim to be the best at doing the slides and stuff. If you want to see some content of mine that I think is actually pretty cool, I suggest you look at the demos. But yeah, we will post this online, and then I'm happy also to answer questions here. So I want to go back here to this question about for each policy a key pair has to be maintained. So that is somewhat, that's only mostly true, let me say, first of all, because Alice can go offline and the policy will continue. And so that is one potential use case for NuCypher, where you have an access management scenario where you want Alice to be able to disappear from the network. Now, let's say that's not the case because you want to continue to be able to grant and revoke throughout the life of the policy. In that case, it's true. You're right that a policy, each policy is a key pair. But you know, we have storage. You know, we store those keys for you. And actually, to dig just one layer deeper to understand how that works, we derive keys. So every policy has a label. And the easiest way to think about this label, but by no means the only way, but the easiest way is to think about this as being like a directory path, right? And you want to share all the files in this directory. And then, so in Rico, anybody can put files into the directory, and then only Alice and Bob can get files out. So what Alice does is derives, using scrypt, a key pair from a label. Or actually, no, there's really two layers of it. She derives her deriving material using scrypt, and then I think she derives from the label using poly 1305. So really what happens there is, as long as you have the deriving material and the label, you don't actually need to keep the key pair. You only have to keep one set of deriving material, because it all ends up being derived from the deriving material. But even if that weren't so, the NuCypher application, our command line application, does the key management part for you. So you really don't need to think about it too much. We have not yet done any documentation for like how to back up. Obviously that's something that we will need to have long before mainnet, but hopefully not an issue here for this hackathon. I would imagine that most of what you're going to be building is sort of ethereal in nature. So I don't know how great an answer that really is. I think generally, to sort of reflect on that is, there are scenarios where Alice doesn't need to maintain the key pairs, and the scenarios where she does, NuCypher does it for you. And even if you want to do it yourself, all you really have to do is custody the deriving material.
Hey,
Yeah, go ahead.
yeah, hey Miles, this is Vishwas. I just asked that question.
Yeah.
I have one doubt left. So it looks like it uses the PBKDF2 methods to generate the key pairs using that label which you said. Today I was playing around with the Alice and Bob and then the like whole thing. And so my question is, what if somebody else gave the same label? Then would the public key and private key will be same for that policy?
That's exactly right. And that's exactly what you'd want, right? You'd want Enrico to be able to encrypt for the same public key, but then any number of Bobs who are authorized on that policy to be able to retrieve the data by engaging the network. So in other words, if two different Enricos each put a file in the same directory and two different Bobs have access to that directory, then you'd expect both Bobs to be able to get both files, right?
Right.
So that's how that works. Now, again, you don't have to think about labels as directories necessarily. You know, they can be, you could use labels however you want, but indeed, you're absolutely correct when you say that a given label for a given Alice will result in the same key pair. A given label for a given Alice will result in the same key pair, which is exactly what you'd want. Next question, we manage data sets 30 to 50 megabytes in size. Would that be feasible to manage by NuCypher? So just to be clear, NuCypher does not do storage of the encrypted data at rest. We envision that you will use a side channel for that, and we'll build tooling around those side channels, IPFS, Swarm, whichever we think is sort of most viable in the weeks leading up to our mainnet launch. The way that we typically imagine dealing with large data, and of course 30 to 50 megabytes is by no means large for today's decentralized data sharing standards, but the way that we'd imagine doing 50 or 500 or 5,000 megabytes is with sort of a double encapsulation scheme, where the secret that you'd share using the NuCypher network is itself a symmetric key, and then you'd use that symmetric key to encrypt the data. There already is an encapsulation that happens within the NuCypher network. You'll occasionally, if you want to really seem like a NuCypher insider, you can talk about this as a double chimney scheme. That's kind of an inside joke that we have. But yeah, we do imagine in scenarios with large data that the secret that you share across the NuCypher network is itself a symmetric key, which you then use on the bulk data. Next question. Do you have a way to destroy the rekeys if requested so that you wouldn't be able to grant again? Excuse me. We do have a destroy command, but we've gone back and forth on deprecating it in favor of just letting the user manage their own directory. If you're Alice, so you run, you know, I happen to have an Alice running here, so you can kind of see what it looks like here. I've done NuCypher Alice run, and I use one of our load balancers, and you get sort of this situation here. Alice is now running. If you are running an Alice, you and then you want that Alice to disappear and ensure that there's no ability to grant or revoke again, you have to delete the keys yourself. And there's no sort of computational verifiable destruction type thing. You know, so yeah, you're a single party custodying a single set of deriving material from which those keys are derived, and so you need to delete that deriving material on your own. How can we integrate with Ethereum dApps? Well, that's really the million-dollar question here, and it all comes down to what secret do you want to share, and who has access to that secret, and who needs access to that secret. Integrating with Ethereum dApps generally means figuring out which parties are which characters. So your one side of your dApp is going to have the authority, right? The authority to the code that is going to grant access. And there you will, again, go ahead and look at our documentation. I'll pull it up actually right now. So here I will show our character control guide. So these are HTTP endpoints, and this message is really for real. They are very much a work in progress. You will probably see them change during the course of the hackathon, and we're happy to build new features during the course of the hackathon. Just feel free to come right into Pow General and ask. But what you'll do is you'll hit these endpoints. So we have Alice. Alice can derive a policy key, can grant, Bob can retrieve data, and Rico can encrypt a message. So within your dApp, you will run the NuCypher CLI application locally with whichever character you need, and you will hit these endpoints. We also are working on rolling out an IPC platform so that you can build stuff like that uses Connect Native, like a browser extension type scenario. And we also ultimately will support MetaMask as well. But for now, an easy way is to either, if you're writing your thing in Python, which we love Python, I hope that's obvious. Our code base is over 99% Python. We contribute very actively to the Python blockchain ecosystem. If your thing is in Python, then you can just import NuCypher and go to town. If not, and you want to use the HTTP endpoints, those are documented here. And one of those two scenarios is the way that you'll do your hackathon project if you're writing an Ethereum dApp. Can I provide some information about how GitHub uses private repos keys? I don't understand that question. I don't know what that means. How GitHub uses private repos keys.
Someone in the Zoom chat asked that. Let me get some clarity there.
I'm sort of trying to think about what that might mean.
Hello there. That question that you just said, asked by me, Faizan Ahmed.
Yeah, yeah. Go ahead. What was that?
Yeah, actually, I was trying to access GitHub release through API, and I was getting some page build error. So I want to make that repository private, but then I want to be able to access it. So can you give me some information about that?
I actually don't know a lot about that feature on GitHub. If you want, you feel free to ask that in our Pound General, or maybe there's some GitHub support I can direct you to. I don't know a lot about taking a public repo and making it private, and then what changes there might be to the API. I'm sorry, that's just not something that I'm familiar with.
No problem. Thank you.
Okay, what tooling we're working on, or tooling ideas for the hackathon? Well, we want MetaMask integration. We want a solid browser extension. A couple people have already really started on browser extensions. We want, as far as tooling, we'd love ways that make it, ways that really make a foolproof sort of scaffolding for Ethereum or other dApps. So really, it kind of depends. You know, well, I think what we'd like to see for tooling is for you all to build some basic applications and then see what tooling you think is missing. Probably a browser extension is a reasonably obvious one, but from there, we'd probably like to see what you think is missing as you build. Next question, which encryption algorithms do we use to generate the respective keys? I'm not sure what you mean by respective keys. We derive the material that we use to derive using scrypt with difficulty of 20, input length of 16, and then we use Poly 1305, I believe, to derive from the label. I think that was perhaps in motion recently, so there might be a pull request that changes that. But as far as I know, we're still using you know, Cha-Cha 20 Poly 1305 to generate to do the ultimate deriving. Next question: for Bob to receive a message, they must create a public and private key pair. Could the key be generated without NuCypher, just like with OpenSSL on my local machine? Yeah, the answer to that is generally yes. With the proviso that we do expect the key pair to be valid on the SEC P256K1 curve at the moment. We've thought about supporting other curves and stuff, but for now, we do expect that those keys will be valid SEC P256K1. So if you are capable of generating valid keys, you can do that with your own tooling. Yeah. Next question, tooling. What features do you want in the browser extension? Well, we have imagined, and actually someone has already worked on a little bit. We can dig that up for you if you want. Happy to dig that up for you. We've imagined sort of an IPC scenario, inter-process communication scenario, where the Connect native web extension API is used to launch the appropriate command line entry points. So this is like grant and revoke for Alice, retrieve for Bob, join policy for Bob. So perhaps, you know, and I don't know, I think sort of exactly where the rubber meets the road here in terms of how decentralized apps use.
Hey, Miles, this is Elvi.
Yeah, go ahead.
The one who asked that question.
Yeah, go ahead.
So when you mean by IPC, you need to communicate browser to your locally running Alice, Bob, and Enrico system, or
Exactly.
are you communicating to the browser?
Exactly. And in the scenario of Connect Native, perhaps fortunately or unfortunately, depending on your perspective, Connect Native wants you to specifically use the standard in and standard out of a launch child process. So we actually we just merged less than a week ago, excuse me, a number, a bunch of plumbing that sort of takes the high-level character methods. Again, I'm talking about grant, revoke, retrieve, join policy, encrypt message, and interfaces them through our various control endpoints. So we have the HTTP control, we have standard in, standard out, and then we're going to have sort of general purpose IPC tooling. So, excuse me, one moment. So in the case of the browser extension using Connect Native, one imagines there that you'd launch a short running process and gather its standard in and standard out. I'm sorry, you'd provide the metadata via standard in, and then it would do its
message passing.
Another scenario there is that you might launch a long running process using Connect Native and continually use its standard in. We can support either of those scenarios, and there's a bunch of that sort of thing that you'd love to, that suddenly NuCypher would be much easier to use if a browser could do all that stuff. Now, it's not clear to me in the ecosystem exactly what's going to happen. Like, there's MetaMask, obviously. So does that sort of preclude NuCypher and Origin and Live Peer? Like, are we all going to have our own browser extensions that run our own? Like, is every project of this nature that has some local process? Say again.
Previously, I worked with MetaMask extension, which provides provider directly connecting to the Ethereum or Web3 provider. So if the NuCypher has something which has related to the Web3 or Ethereum blockchain, or any blockchain which MetaMask does provide, like XDAI or PO chain, whenever there is a change in a blockchain, you can get exactly the provider and just pass the messages. That there is an repo for that. MetaMask has provided the extension provider, which might be useful, but where it comes to the place where does that fit into the NuCypher ecosystem?
Yeah, listen, I mean, I'm all for that scenario. I love that idea at a high level, and we experienced it a little bit at ETH Denver, where there was a fairly simple in-browser implementation using XDAI to buy food at the food carts.
Yeah.
The problem there is, and this is not just with NuCypher, but this is with a lot of the sort of upcoming cohort of layer 2 projects. There's local processing that has to be done. If you're Alice, you have to custody the keys. You have to derive the keys, custody the keys, perform the grant, or perform the revoke. If you're Bob, you have to custody the key and retrieve and do the decryption. If you are Enrico, at very least, you need to custody a signing key, but Enrico is sort of maybe the closest one. One way or another, there's a local process that has to run that you want locally because you want to custody the keys locally. And so that part of the loop, at least in my opinion, is not closed yet in the ecosystem in terms of how that will all work. I mean, of course, MetaMask just custodies your wallet keys, which is not quite sufficient for any of the upcoming cohort of layer 2 projects. So I think it's reasonable to say that there's an open question about exactly what the user experience will be there. Will you launch a locally running, long running process and then go into your browser and bang on it with, with JavaScript and then use MetaMask for the wallet part, the ultimate blockchain authority part? Will each of us have a browser extension that works in concert with MetaMask? Will there be sort of a third solution where there's a generalized IPC Connect Native tooling that is used to launch local cryptographic processes that are meant to then be used with MetaMask? I don't know. And I don't think anybody exactly knows. So that there's a lot of interesting work to be done in that space. And some of that might be good work for this hackathon.
Yeah, great.
Okay, Bikram says, JavaScript library for sure is missing in my humble opinion, smile face. Yeah, well, we now have HTTP endpoints that your JavaScript thing can hit. So if building a JavaScript library is something that speaks to you, then that's something we'll happily take a look at, of course. Is the core tooling around, by the way, I think a JavaScript library at this point, if you were using our HTTP character control, will end up being quite thin, I think. Is the core tooling around, this is DRBH, is core tooling around IPFS, store tree pin created? If not, would people want this? Oh, heck yeah. No, it's not created. Do people want it? Absolutely. Not just IPFS, but Swarm too would be pretty groovy. And, you know, heck, I mean, even sort of general purpose, SCP tooling. Yeah, side channel tooling is an idea whose time has come, and do feel free to build it.
This is the person who asked that question, and I'm looking for a team for the hackathon. So that would be a perfect topic. If anybody wants to work on that, please reach out to me.
Yeah, I mean, building core tooling around IPFS that treats IPFS pins as it sort of gives you a relationship between a pin and a NuCypher label. That'll be so groovy. I mean, if y'all don't build it, we will. So that tells you something.
Yeah, awesome. Thank you.
While integrate with DApps, as you said, we can use the endpoint of your NuCypher, so all key partner have to store in the centralized DB. No. In no scenario do we imagine key pairs being stored in a centralized DB. The testnet our DevNet that you can use here is just so that you don't have to run your own nodes. You don't have to run your own Ursulas and sort of go through the process of keeping them up. So we provide a DevNet for you that essentially just simulates what you will have on mainnet. Now, what it doesn't simulate, and I guess I maybe glossed over this a little too quick, so let me just spend a few seconds on this. What it doesn't simulate is the crypto economic portion. So you don't have to pay, Alice doesn't pay for DevNet, but I think it'll be pretty obvious when you are getting ready to grant that will be the moment when you need to have access to a blockchain wallet, in this case, an Ethereum wallet, so that Alice can pay for the policy in Ether. But our DevNet is not to be understood as a key store. It's just a network so that for the purpose of the hackathon, you don't have to think about running your own little testnet of NuCypher nodes. What is the command line argument that is regenerating the keys on startup? I'm specifically trying to make sure I startup actors the same way so that they are the same actor. Well, excuse me, I'm sorry. If you want to generate new keys on startup, you can always start NuCypher with --dev. Oh, and there's Tux right there answering that question. As far as starting the actors the same way so that they're the same actor, really you just need to have the same deriving material and they'll be the same actor. So you need to custody that deriving material. Could a core.js library replicate all of RESTs that would be useful for NuCypher? Well, a JS API library. Yeah, sure. The thing that we don't, so, you know, at a high level, a lot of the ecosystem is in JavaScript, right? We know that. We are in a position of rolling our own crypto. So we've already sort of crossed that Rubicon, right? We did the research, we built this proxy re-encryption primitive, and we've rolled it together. I hope you have some sympathy for our position of not wanting to do that in JavaScript. Obviously, we were going to do that in Python. We've also actually started a Go implementation, but you know, the security robustness and security tooling and just general cryptological tooling in Python made it sort of obvious for us to do that stuff in Python. So that's what we don't want to end up doing is the low-level crypto stuff in JavaScript, because we think that it will invariably invite a number of, not only a number of attacks, but a number of attacks that we don't even necessarily know about or can't really threat model with ease. There are some known unknowns, like how to mitigate timing attacks in JavaScript, that sort of thing. But there are also unknown unknowns, and you know, I think you have to acknowledge that. So what can a JavaScript library do ends up being the question. And yes, I think that your point that it can replicate the REST endpoint so that you end up with high-level JavaScript tooling that hits our, by the way, I don't even call them REST endpoints. Let's sort of just agnostically call them HTTP endpoints. Yeah, it's possible to imagine that that's exactly the right layer for a JavaScript library. Now, it's also possible that you'd want to use a JavaScript library in concert with a browser extension that then uses Connect Native. So maybe we'd want a JavaScript library that's sort of agnostic to that underlying transport layer. That is well, in addition. Use a persistent character. Oh, here we go. Yeah, Kieran posted the configuration guide, currently called Ursula configuration guide, for persisting characters for you there, Travis. Let me take this moment to say that I think it's already obvious, hopefully, that our code base is in a very high velocity way right now. Our documentation even more so. There are things in the documentation, low-level specifics to the documentation that we're probably going to need you to tell us are wrong, changed names and things. I already know there's at least one endpoint in the character control guide that I think is incorrect now, and we will be fixing that up here in the days to come. Essentially, the low-level NuCypher protocol is something that we've developed over the course of the last year, and we feel really good about, and that is solid. What is in constant flux right now, starting about a month ago with the ETH Denver Hackathon, is all of the tooling. Yeah, that's it, Vishvash. Derived policy encrypting key. The tooling that we're trying to provide for hackathons is totally in flux right now, and a lot of that tooling is hitting underlying infrastructure that's pretty solid. So that is probably what you're going to see happen throughout the course of this hackathon as you ask us for support. And by the way, it's not only support for broken. It's not even primarily support for broken things. There are going to be some of those, so be forewarned. But it's also things that we need you to tell us to emphasize and build, and we are happy to do that because we're moving very fast right now. Any other questions?
Regarding the nodes.
Yeah.
So how are you going to incentivize the nodes, and are these nodes or something one has to host on a cloud platform, or someone can host it on their local environment or local host?
Do you mean for the purposes of this hackathon, or are you just talking about the NuCypher network in high-level terms?
NuCypher network in high-level terms.
Yeah, so we expect people will host nodes in all kinds of places in all kinds of wacky ways. We've even occasionally thought about supporting ARM architecture, although I can already feel Tuck's about to launch some fireworks into the channel here. We've even thought about having people co-locating their Raspberry Pis and running nodes that way, but that's not something we're going to be supporting out of the box, I don't think. But yeah, we are imagining people running nodes in a sort of radically distributed way. We have a pull request open right now that has Docker tooling with exactly that idea in mind, that you can run a test dev net. In other words, not really fully a test net because you don't have the distributed economics, but a test dev net locally via the Docker, and then eventually, presumably, that will evolve into running a node in Docker that you can do anywhere you like, whether it's your basement or on AWS or wherever.
And these nodes are the pathways for the Enrico to find the files and encrypt files, right? If I'm not wrong. People who are, these nodes are Ursula's and Enrico's in general. Is it right?
Your very first part of the question cut out for me. What were you asking? Who are Ursula's and Enrico's?
The nodes which peers who are running the nodes, these nodes are nothing but the Ursula's and Enrico's in general.
I mean, in general, I'd say they're nothing but Ursula's. Now, it's true that people will, so all Enrico does is encrypt the message. Enrico doesn't directly interact with Ursula in any way. Enrico encrypts the message, puts it on a side channel, then Bob goes and grabs the encrypted message, takes it to Enrico and asks, takes it to Ursula. Sorry about that. Enrico encrypts the message, the prize, the secret, puts it on a side channel. Ursula goes and Bob goes and grabs the encrypted secret, brings it to Ursula for re-encryption. So Enrico and Ursula never directly talk to one another. Now, in the real world, for many decentralized application use cases, we do expect that there will be sort of long-running streaming Enricos, but we take no opinion on that. They're not part of our, they're absolutely excluded and intentionally excluded from our crypto economic notions. Enrico is an independent actor. Anybody can encrypt for the policy, and we take care to make sure not to be able to stop that.
Oh, in a way that is, it's on layer 2 and communicating the real world. The message passing from the nodes to Ursula and back from, and Bob receiving back the text is everything on the layer 2 interface, right?
Right.
If we everything on the layer 2.
Right.
So
yeah.
if you're going for tooling, it wouldn't be a better option having the node address or like pool address directly communicating to the those nodes than having natively running application locally on the machine?
For which role now?
If considering the browser extension, which has to communicate, like we were talking before, we were talking about browser communicating by IPC to the locally hosted environment, NuCypher environment. So if a browser extension directly communicate HTTP endpoint directly to the nodes, wouldn't that be much preferred, user hassle-free, less friction for user to onboard to the NuCypher ecosystem? Wouldn't that be a better option?
I want to make sure that I'm really understanding your question. I think I'm hearing you ask, doesn't it make more sense for the browser extension to talk directly to the nodes?
Yes.
Yeah, well, the thing there is then, where do you do so Alice needs to perform this threshold rekey operation.
That is compute intensive. Okay. So that has to be natively run to compute, which is compute extension. So,
I mean, does it have to be? I think that's clearly the best way, because you want to locally custody the deriving material and the keys, right? You don't want that out there. And you know, a huge part of the point here is that you now have local custody of this private material.
That's one, but the use cases where the DApps needs this data privacy, which are accessible via DApps on the Web3 platforms or just on the browser platform. They might run their own LSS platform, LSS node on the cloud, and they just have to route they pass the data in that scenario where if someone has to interact, considering everyone is the Ethereum blockchain and they want to pass the messages, the DApp doesn't want to run wants them to run this LSS encryption or policy making locally, but they would rather prefer to host it on the cloud where they can pass it and get it encrypted and to create a policies for the user.
Yeah, so I don't want to preclude that as an idea for the network, but the way where my mind goes when I imagine that division of responsibility is I imagine that that's something that the DApp itself does. In other words, the DApp is a web app, and it is locally running an Alice, let's say, for granting, and so that's not something that is. Look, it's totally possible that there's widespread use case for sort of pre-enabled cloud model. Frankly, I'd call it a centralized model, but a pre-computed cloud model, or I'm sorry, a sort of prefab cloud model where you expect to be running Alice on the cloud, or Bob. That's totally possible. Whether or not we'd have a scenario where the browser extension does that specifically, I am pretty skeptical there, because I would imagine that what you'd do in that scenario is the application would be the web server. Inside the application would live Alice on one end and Bob on the other, or maybe Enrico. And you simply hit that web application with ordinary JavaScript, understanding then that custody of the private material for both characters now lives on the cloud. And so if that's what you want, then I would expect your DApp to just sort of have a bolted on HTTPS endpoint to do the things that your DApp does. It's totally possible now that there is widespread enough demand for that we'd want to include some tooling in the NuCypher code base, but it's not even exactly clear to me what that tooling would be, because the special sauce that's going to happen there inside your DApp is something that, you know what I mean? In other words, the only thing you're really dropping into the middle of the request response cycle is the thing that your DApp does. And so for that reason, we have usually imagined that character control is a local concept. In other words, that character control follows key custody, and that those have a one-to-one relationship. But I'm interested in talking about this more. I mean, maybe there's a quasi-centralized cloud use case that is broad enough and also generic enough that kind of tooling can be made. But color me skeptical for the moment. I think that my sense is that what's going to happen there is that every DApp is going to have basically totally different things happening inside that request response cycle, and so that there's not enough there to want to share tooling. But you know, I don't know. I'm happy to be proven wrong on that.
Yeah, so we're closing up, over an hour here. Justin, thank you so much for this presentation. This was super informative. It sounds like a bunch of people were able to get their questions answered. If anyone else has any questions, please post in the Discord. We can continue that conversation there. But yeah, Justin, thank you so much for this. This was really, really awesome.
Sure, I'm super happy to, and I really, really look forward to meeting everyone a little more closely on our Discord and interacting with you over the course of the next couple of weeks.
Awesome. Thanks, everyone. And don't forget to post your project updates today in the CoinList Build Room.
Farewell.
Bye.